Welcome to today's Explainer. Take a quick second to think about your everyday experience of reality. You know, the way you feel time ticking away, the way light bounces around the room you're in, the sheer physical space you occupy. It all feels so incredibly reliable, right? So absolute. But out there in the depths of the cosmos, there are these enigmatic, absolutely awe-inspiring locations where every single rule you intuitively understand about reality just shatters. Imagine a place where gravity is so overwhelmingly powerful that it actually warps the flow of time, and where not even a single photon of light can escape its grasp. These cosmic monsters are what we call black holes.
But right off the bat, that brings up a pretty massive paradox. I mean, if light can't return to our telescopes, how do we even know they're out there? How do you see the invisible? Well, today, we're going on a fascinating journey through our source material to answer exactly that. We're going to travel from the spectacular, violent death of a massive star straight to the most dangerous, time-bending edge in the cosmos.
Okay, let's dive into this. What actually is a black hole? It's a term we hear all the time, right? Sci-fi movies, pop culture, it's everywhere. But when you strip away the Hollywood myths and get down to the actual astrophysics, the reality of what these things are is way stranger and honestly way more terrifying than anything you'll see in the movies.
To really understand it, we need to clear up a super common misconception. A black hole is not just some empty void or a giant cosmic vacuum cleaner roaming around space. Actually, scratch that, it's not a hole at all. It's a gravitational object formed from an insanely concentrated state of matter. We're talking about an enormous amount of mass packed into an unimaginably tiny, microscopic region. And because of that extreme density, it heavily, violently distorts the fabric of space around it. And since space and time are permanently linked together, it fundamentally distorts space-time itself. That intense warping creates an inescapable trap. But to really grasp how something so extreme even gets made, we kind of have to go back to the beginning.
We need to rewind the clock and look at the origin story of this phenomenon. It all starts with a massive star. A star that has been shining and burning incredibly bright for millions, maybe even billions of years. And you know, stars aren't just sitting there peacefully in the dark. They are engines of intense, unimaginable power, and they are constantly fighting a literally explosive battle for their own survival.
And this brilliantly illustrates the delicate cosmic balance happening deep inside every star. It's basically a billion-year tug of war. On one side, you have nuclear fusion constantly firing off in the core, generating massive amounts of energy that pushes outward. On the other side, you have the immense inward pull of gravity, just constantly trying to crush the star under its own astronomical weight. For millions of years, these two forces are locked in a perfect stalemate. The outward pressure flawlessly balances that inward pull.
But here's the catch. Stars don't have an infinite supply of fuel. Suddenly, eventually, the core fuel runs out. The nuclear fusion slows down. That absolutely crucial outward pressure violently drops. And gravity finally wins the tug of war. In a fraction of a second, the star's core catastrophically collapses inward under its own massive weight. This happens so incredibly fast, and the collapse is so severe that if the mass is large enough, it punches right through the fabric of space, giving birth to a black hole.
As that core collapses in on itself, gravity becomes locally supreme. Let's just conceptually slow down here for a second, because as we approach this newly formed object, we are coming up to the most terrifying, absolute boundary in the entire universe, a boundary where the rules of reality change forever.
We call this the event horizon. It is the absolute point of no return. Think of it as a cosmic threshold. If you're hanging out just outside the event horizon, theoretically, if you had enough energy, you could still fire your engines and escape the black hole's gravitational pull. But the very moment you cross this line, it's like stepping off a cliff in the pitch dark. There is absolutely no path back. Not for the most advanced spaceship, not for fundamental particles, and not even for light itself. And because light cannot escape to reach our eyes, the black hole appears entirely dark, completely hiding its core from the rest of the universe.
Let's move to and see how this builds, because black holes don't just consume matter and swallow light. They do something far more unsettling. They fundamentally challenge our very concept of time. This right here is the true weirdness of a black hole, and it's where astrophysics gets profoundly mind-bending.
To understand why this happens, we have to look at Einstein's theory of general relativity. Our source material highlights this profound concept. Gravity doesn't just pull objects toward each other. It actually curves and distorts space-time itself. Imagine space and time are woven together into this single, seamless, trampoline-like mat. When you drop a massively heavy bowling ball, our black hole, onto that mat, it severely stretches the fabric. And here's the crazy secret. It stretches the time threads just as much as the space threads.
So, the crucial point is time literally slows down. Take a second to just let the immense weight of that physically wash over you. This isn't a sci-fi trick. It's not an optical illusion, and it's definitely not a malfunction in your clock. The extreme gravity at the edge of a black hole physically acts as a giant brake pedal on the flow of time itself. It is a literal, physical warping of reality.
And because of this, reality literally splits depending entirely on your perspective. If you were a distant observer, safely floating far away in your ship, watching an object fall toward that event horizon, you wouldn't see it fall straight in. Instead, you would see the object slowing down more and more as it gets closer, eventually appearing to freeze completely right at the edge, slowly fading to red. But for the object actually falling in, their watch ticks totally normally. They wouldn't feel time slowing down at all as they cross that terrifying threshold, even while the rest of the universe outside is speeding by. Black holes prove, without a shadow of a doubt, that time is not some universal ticking clock. It is completely relative.
But let's pull ourselves back from the dangerous edge of the event horizon for a second and look out into the wider universe. Because this brings us right back to the paradox we started with. If black holes trap all light, and if they freeze time at their borders, how on earth do we actually detect these invisible giants hiding out there in the dark? Now, what's really interesting about this is the beautiful irony in astrophysics. To find the absolute darkest objects in the universe, scientists actually look for the brightest, most violent effects in their surrounding neighborhood. We look for the invisible clues. We watch the motion of nearby stars. If we see them being whipped around some empty, invisible point in space at crazy speeds, we know a monster is lurking there. We look for superheated gas and dust swirling furiously, and we look for the massive emission of X-rays and intense radiation being blasted out into space. We don't see the black hole directly. We see the absolute chaos it causes.
And that chaos often forms something truly magnificent, an accretion disk. This is a highly luminous structure made of gas, dust, and torn-up space material orbiting at incredible, mind-blowing speeds right around the black hole. Because the gravity is so intensely strong, this material is whipped around so fast that the sheer friction heats it up to millions of degrees. It glows intensely, blasting out high-energy X-rays. So right next to a sphere of pure absolute darkness, you actually have one of the most blindingly bright cosmic structures in existence.
Which brings us to the ultimate mystery. We know how they form, we know how they bend time to a complete standstill, and we know exactly how to spot the glowing disks around them. But what exactly is inside the black hole? Once you actually cross that event horizon, what horrors or wonders are waiting for you in the dark?
Is there truly a singularity at the very center? An infinitely small point of infinite density where all that mass is finally crushed down? Inside this object, the greatest scientific minds and the very laws of physics as we know them might just completely break down. Our current understanding of the entire universe fundamentally hits a brick wall at the event horizon.
And if they are the ultimate endpoints of massive stars, the final, undisputed masters of gravity and time, do black holes last forever? Or does even the most powerful cosmic monster in the universe eventually meet its end? That is the profound, lingering mystery that the universe leaves us with. These objects show us just how incredibly powerful gravity can be, and they constantly remind us that our understanding of space, matter, and the flow of time is still beautifully incomplete. Thanks for joining this explainer on Chapter 1 of our cosmic journey.